Hello and welcome to another episode of Coffee with Thorben. Today with a great guest with Gerrit and Meier. First of all, sorry everyone for the delay. I had a few issues integrating Garrett's audio into the stream, but now I think we figured it out. Garrett, welcome to today's Coffee with Thorben. I hope you have a coffee or tea or whatever you
Yeah,
prefer.
at least a tea. Thanks for the invitation, Torben.
So,
Nice to be here. And yes, it was my audio that was faulty. Of course, it's not the Windows setup Torben has. No, of course
no,
not.
of course. Why should it be a Windows setup, right? I mean, if it would be a Linux setup, then I would totally get it. But with Windows, it
Yeah.
just usually works. Um, okay, for everyone who doesn't know you, that's probably
Yes,
not more than one.
everybody.
For everyone who doesn't know you, please tell us a little bit about you.
Yes. So first thing we got right is my name is Garrett. So German pronounced. I'm working at Neo4j, like Michael does. So you had him as a guest, I think, a few months
Yeah.
ago. So that's nothing that we want to get into Torben's live stream every time, but we both know Torben, and he kindly asked us to take part of this Coffee with Torben sessions. And yes, I'm with Neo4j for more than 3 years now, working like Michael with him on the Spring Data Neo4j project. And yeah, we are happy to announce a new version coming up this month, end of this month, driven by VMware. Before I started to work at Neo, I was more or less full in consultant, besides 3 years break for project development. But yeah, I would see my career as being a consultant and then with fancy titles, and then coming back to being a software engineer at Neo4j. I'm really happy to be there
Yeah.
since the first day.
Awesome. So yeah, and at Neo4j, you're mostly working on the Spring Data integration and on the Java driver, right? So
Exactly. So we work close together with the driver team. That includes not only the Java driver, but also drivers for other languages. And of course, when we discuss something, we are also taking part of the development of the Java driver, but not mainly.
okay.
So we are more supportive or requesting features, like we need a certain API for Spring Data, for example,
Yeah.
similar.
So you're obviously the perfect guy to talk about the new Spring Data Neo4j module. But before we go there, for everyone who's well, I'm mostly talking about working with relational databases on this channel on the blog, right? So for everyone who's not so familiar with Neo4j, can you give us a very quick rundown on what actually is it and why should I use it, or when is it better than
Yeah.
the database that I might have been using for a while now?
Um, so basically, I hope that my description of Neo4j is not orthogonal to that what Michael did. So Neo4j is a graph database. That means in the simplest explanation I can give, we talk about circles and lines. And sometimes these lines have arrows at the end. And those are called relationships. So basically, you have a graph that contains of nodes, as we call it, and relationships. And they are more or less heavily connected. That brings us to the main point. When should you use Neo4j? That's when you have highly connected data, or you have not the amount of relationships between two nodes, but you have a graph of information. That means you can jump through your whole data following relationships. You might have heard of Neo4j in combination with the Panama Papers, or lately there was this bank scandal, let's call it scandal, that got uncovered by the ICIJ, so the International Consortium of Investigative Journalism. And they, for example, are using Neo4j to make sense of their data. So mostly they get information from whistleblowers. They collect all the information, for example, in the graph database, and then try to structure them and query them. So like they find a certain pattern when we speak about the Panama Papers or Paradise Papers, how people do tax evasion, and they can apply this search pattern against the database to get the relationship between people, money floating around, etc.
Yeah, and if I remember that correctly, one of the key elements there was to be able to track a long list of money transfers, which is basically a very long graph through the data to figure something out.
Yeah.
Which is something that is a challenge in a relational database.
Yeah, so we can make fun of, but I think it's something more serious when we have this whole cascade of joining data in a relational database. It can be sometimes hard to A, get a query right, and B, get the performance out of the system. So the n plus friends problem, for example, if you have a Facebook friends graph or similar. And this is something we also tried to expose via our query language, Cypher, that you can really describe it in some kind of ASCII art, how you want to fetch the data. And I think if you can just apply these ideas, and of course, it took also for me a little bit of time to get into graph databases, because previously you solved every problem with a relational database. But it makes sense when you really have this this amount of data. It's not only the amount of nodes or relationships we are speaking of, but the amount of relationships in the depth. So if you have to dig deep into the data and find patterns, graph database makes sense to use.
Yeah. Which is a slightly different use case than we have with a typical relational database.
Of course. Yeah, there are also downsides. Yeah. For example, Neo4j per se is has no schema, so you can put in data however you want. You can put labels on nodes so to identify them, but they are not strict to someone.
Yeah.
So we have indexes, we have constraints, of course, that you can get a little bit of control over the data, but you have also the freedom, if you do not rely on constraints or similar, that you can throw first everything in there.
Yeah, so when I get asked, okay, when should I use a relational database and does it make sense to take a look at a graph database like Neo4j, I always try to explain, okay, if you have a highly structured data model, then and you have to define queries based on that model without lots of joins, then you're probably then the relational database is probably a good data store for you. If you have something where you need to traverse lots of associations, for example, we discussed using a graph database for tracing use case or tracing application, where we would have to create queries on a relational database with probably a few hundred joins. Then, well, you already see in the SQL statement that the relational database is probably not the right tool for that. But I would say a graph database is a much better fit for that.
Yeah, and
As
to be honest,
yeah.
I have to work with the Neo4j since 3 years, but it still makes fun to play around when you have data.
Yeah.
Like I said, it's encouraging to have this nice query language. Also, I don't think that this is heavily used in enterprise business, but when you spawn a Neo4j instance, you get a Neo4j browser with you where you can colorful see all the data floating around and the results of your queries. It's yeah. So if you haven't checked out the Neo4j, you should give it a try. There are several ways to get an instance, starting with an easy desktop application where you have a full-fledged enterprise version in there. Pull a Docker image, or go full in and install the server variant. But you will have the browser in all of them.
Yeah.
If you do not disable it.
Yeah, and I totally agree with you. So if you haven't tried it, give it a try, play around with it. The worst thing that can happen is that you had fun for a few hours in the evening and learned a little bit. But you might even figure out that this might be a great fit for the application you're currently working on. Because the focus is different. You can answer different questions with it, and working with deep relationships and really highly connected data is much easier with the graph database. Okay, I want to quickly take a look at the chat. Because I was asked if we will answer questions today. Yes, of course we will. So if you have any questions about Spring Data, especially Spring Data Neo4j, graph databases, differences between that, then we will answer them during our conversation. And if we have some time at the end, I will also pick other questions from the chat. If you have something that's strictly JPA or Hibernate related, I would like to ask you to wait with these questions until the end of the stream. And if we don't have a chance to answer them there, then we will do that later.
So, I just jumped in full screen, so I'm now Thorben and Garrett.
Yeah. Yeah, full focus on you.
Perfect. I just want to something when we speak about the tryout of a Neo4j instance. When you have a relational database, we have a tool coming with the desktop version that allows you to move your data from relational database into Neo4j. So you can give it does an analysis, and then you can give it a few hints where a mapping table might be a relationship, etc., which direction, and similar. Yeah, just this commercial break.
Yeah.
Sorry.
Okay, so we wanted to talk about the Spring Data Neo4j module. So when we talked the last time about Neo4j and Spring Data, I think it was with Michael, then he told us about the OGM Spring Data module, and you guys now came up with something new. What is it, and why should I prefer the new one, and what happens to the old one?
Yeah, so I think I separate the questions. So yeah, why you should consider, well, what's in the new version?
Yeah, what's
and
new?
why should you consider it to use? So the next version coming out end of the month is Spring Data Neo4j 6. It's a complete rewrite of what we have done before. That has several reasons why we did this rewrite. But mainly we wanted to have take more advantage of the Spring Data ecosystem that's already present. When we look into instantiation of objects and similar, that we couldn't do with the attempt that were there before. So we had Spring Data Neo4j 4 and 5 at least, but together with the so-called Neo4j OGM, so the Neo4j Object Graph Mapper. The background was to have a standalone Java-supported OGM, and then on top of it, the Spring Data Neo4j. You can compare this similar to Spring Data JPA, where you also have an JPA implementation instead of the pure JDBC driver. And yes, as you hear it, there's also another project, Spring Data JDBC. And we looked at it and said, yeah, we want to have something that simple again.
Yeah, let me interrupt real quick. So OGM stands for Object Graph Mapping, right? Exactly. So it's basically a mapping to object like we know from JPA. Yeah. So it was, when using it, it feels relatively similar from the general concepts, because you have this object map. So in the back, there's of course a graph database instead of a relational one, and all these kind of differences, but the idea is similar. Let's say it like that.
Exactly. So you have your annotated model. We still have this, of course, to get this schema for our mapping. But yeah, and the session handling in OGM is more explicit than it would be with JPA, where you can just modify your objects and be safe that everything get persisted, but you have in OGM, for example, this explicit calls and no lazy loading, yeah, and similar. But yeah, we saw for mostly Spring Data JDBC and thought about having just a driver as a dependency for the connection to the database, to make things also for the users easier. It's not that we want to make our lives easier. It's also more intuitive for the users. So people who were using Spring Data Neo4j with OGM had two mapping frameworks. So Spring Data Neo4j took a little bit of mapping and instantiating. On the other hand, the object was then passed over to OGM for further mapping. Just to explain a little bit. So there were no really separation of concerns there. Other things we found in OGM, like support for multiple transport modes, I come to this in a bit, and heavy caching of the result set were not, in our point of view, not future-proof anymore. First of all, transport modes. OGM gives you the ability to connect to an embedded instance, to use an HTTP connection, or to use our binary protocol that is driven by the driver, Bold. Also, nowadays, I would advise not to use an embedded instance of Neo4j within your application, because you get all the downsides you will assume when you have a database running in the same JVM as your application. The database itself is heavily optimized when it comes to garbage collection, for example, or similar. But maybe your application is not. And then the database will suffer from the jigsaws you produce, the GC you produce, because your application is not optimized. Also, when your application crashes or the JVM crashes, everything crashes. The HTTP approach is something in between. It was the first remote connection to Neo4j. But looking at the difference between the HTTP connection and the driver, the HTTP connection has a few lacks of type informations. So we cannot make use of the full type system Neo4j provides. And as a HTTP connection itself is, we just get raw JSON-like information spec. So we would then have to manage to create the right types coming back from these strings and numbers. And if you are using Neo4j Enterprise in clusters, and you need support to connect to your cluster, you have to take the bold protocol as the only option. That gives us the routing. It gives us the whole type system back, and similar. So this decision was for us very clear to make. And on the other hand, the caches are really somehow constructed like it consumes the whole result, and then it will create the objects out of the whole result set. So with this, we had problems to really say we want to go this reactive way. We want to support the reactive flow that came back that came into Neo4j 4 9 months ago. It's just not possible to have this mapping. So even if I speak about graph databases and graphy data, when you get the data back, you have kind of rows, of course, you get back. So we would need something that we can map on a row-based approach. And taking all these problems as we saw them into consideration and thinking about rewriting OGM to then still get used by Spring Data Neo4j, it got clearer and clearer for us that it is a better approach to drop those functionalities or to fix those faults with a completely new written Spring Data Neo4j based on only Spring Data. So the Spring Data Commons library.
Yeah. So
and the driver for the communication, of course.
Yeah. So to summarize that, you with Spring Data OGM, you had a Spring Data module out there that was used in projects and everything, and you basically learned over the years, and now figured out, okay, you want to separate the concerns of the mapping, not have it mixed as was in the end. You now want to focus on that Spring Data module on the bold driver because it's more powerful. And if I remember the call with Michael, I think he also said that it's way more efficient than your other drivers, and supports database clusters, for example, which is an interesting feature in all enterprise applications. And then take a more reactive approach that doesn't require you to basically fetch everything and map it then on a row-based like approach to the objects.
Yes.
So and you were able to fix all these things with the new approach?
Yes.
Awesome.
That's otherwise I would not advise this. Of course. Yes, basically we had the two cornerstones for us were immutability and reactive support. Luckily, immutability is something we could get when we want to focus strictly on reactive support. But it was also for us very important to have in both programming models the same amount of support. So there's no second-class citizen if we speak about imperative or reactive programming models and support in Spring Data Neo4j 6. But as I said, it was very important for us to have these and to have less surprises for the users. So OGM itself, taken out of the SDN context, had a lot of features in there. For example, like I said, the mapping was we collect all the data, and with this bunch of data, we want to map the objects. On the benefit of this approach was that people could write cipher that did not really match to get just the data we need for the mapping, but it returned more, or it was a little bit more nested or complex, and all the data get somehow tangled together.
So we could basically have the same approach as we know from relational databases. We basically select everything that's in that table, or all the columns that are in that table, but in our mapping we just take 4 out of the 50 and ignore the rest.
Yeah, for example.
Okay. And so, well, I would expect we run into the same performance issues with that approach with Neo4j as a graph database, because selecting everything is just slower than picking the stuff that you actually need for your use case, right?
Yeah, right. But you came away with it.
Yeah.
So without this focus on immutability, for example, you can have 3 rows complementing the result for one object. So other related nodes, etc. Now we are more strict. We say you have to return the data in one row. However, it's possible to do this, no problem about it. But you, on the benefit side, you only get the data back you really need, and the from the database, and then we only have to map what you really need. And I think bringing this idea of formulating queries to the users, if they have to, because we can also generate queries with this high abstraction of Spring Data, it is, I think, also beneficial for the users. We got these problems, for example, with the caching and other things that user wanted to get. We had back then we had a specific so-called depth, so limit or horizon, how far we get the data out of the graph, starting from one node. And then users were surprised when they get the data back and they had more connected data in there. That was because if you fetch all or a limited set of data and A knows B, okay, A knows B and B knows C, where A and B are the same types, and you fetch A and B, but it's also related together, and you want to have one level of depth only. You would consequently also get the chain starting from A to B to C. And that was what users were surprised of, because they said, hey, I want to only fetch the first level. But the BC connection were then made later on and such things. So currently we do not have this depth limit in there. We tried to solve it via cipher statements. Of course, it can lead to performance issues if you have unlimited queries and you are working with, for example, bidirectional relationships or similar things that will then load your whole graph because your schema tells us to do this. But yeah, if you think about your domain model, it is until now the best approach we came up with, and fetch only the data you really need.
Yeah.
Yeah. And so yeah, coming back, it was not something we just dropped in to say we want to do this, but we started, I think 2 years ago with the idea. Yeah, it was around autumn, separately, Michael and me, that we came to the conclusion there must be something like a Spring Data Neo4j Lite, similar. That's totally opinionated, that only works with the driver and does everything how we want to have it. So this got then a little bit of more velocity within Neo4j as we had expected. So thanks to our colleagues. But of course, then the idea of this 100% opinionated mapper was not on our desk anymore, but something more like like SDN was and has on functionality. But yeah, keeping the focus on less surprises.
Yeah.
And I think that's something people would like to see. So we have not forgotten to improve OGM over the time. Of course not. And it will live, I think, for 2 years. But because it's bundled with Spring Data Neo4j 5.3, I think. So that's the latest version, but I do not know what's the long term. And VMware or Pivotal back then decided to have a long-term version of Spring Boot that's bundled with Spring Data within Spring Data Neo4j, of course, and it's Spring Data Neo4j that relies on Neo4j OGM. So we still update there the issues we get in there, bug fixing, etc.
But it's
So
just
it's
bug fixing. It's no strategic development on that, on Spring Data Neo4j OGM.
No.
Okay.
At the moment, no. It's making it stable because we have to keep all the backwards compatibility we have in there. We cannot just throw out API or something like this.
Yeah.
We would love to, but currently we got, okay, that's a shameless self-plug, but we got very positive feedback for Spring Data Neo4j 6 already in the milestone and RC phases. So that we do not see the urge coming from the users to really provide a Java-only solution for this mapping,
okay.
Like, for example, JPA does.
Yeah. So let's talk about the existing users and projects. What actually changes? Let's say I have a project where I've used Spring Data OGM. What should be my next step, and what kind of changes would I need to expect?
So first of all, I think the migration of the meta annotations is pretty straightforward. It might be more explicit on some points, but it's just needed to get this less surprise factor out there. Then you have to arrange yourself with features we have intentionally dropped, not because we cannot provide this, but we think they are bad practices to have, and they shouldn't be there. First of all, my good old friend, when it comes to problems there in OGM, and I have to fix it, is the auto-index manager. So it's something like the auto DDL feature in Hibernate JPA world, where we touch DBA land from the framework. And that's, yeah, so it's indexing and constraint creation via annotations. That's something I also would argue against in the GPA world.
Totally
to have
agree.
this.
Yeah.
But also in the latest versions of Neo4j, there were ever-changing information coming from the database for these fields. So it's a cascade of if-elses to handle every database we support with OGM. And we thought, no, it's the wrong approach to use this. And secondly, I think one user complains and one developer has to fix it in one day because it's not this easy or quick to fix. So it's not worth the effort for us to keep this. I know that people like this during development, but creating a schema with Hibernate functionality might be even a better support for the developer than doing indexes. She or he does not really understand how they get created. Asynchronous. So when you start your application with data, and you also start the database just then, it can be that your tests are slow. The index never get really created because you shut down the database before the index creation were done. And you end up in the very same state when you start the test again. So that's not really beneficial. And on the other hand, Michael created a project so-called Neo4j migrations. That's so if we do not want to challenge our new colleague Florent Beville, who joined us lately with liquid graph. So maybe when you know liquid base, you can think what liquid graph does. And Neo4j migrations is a more pragmatic, not so broad approach to have these schema changes.
Sorry for interrupting. For everyone who's not familiar with Liquid Base is a tool that you can use to migrate a relational database from one version to the other. That's called version-based database migration. And the general idea is you evolve the database schema alongside your application, basically using the same approach. You put out a new release. That means there's a new version of your database, and you provide a migration script. Excuse me. Migration script to get from one version to the next, and Liquid Base can automatically execute that. I haven't used Liquid Graph yet, but as it sounds, that is basically the same for a graph database, right?
Exactly.
Yeah.
And yeah, I do not want to say anything wrong there. I think Liquid Graph is still based on the JDBC driver for Neo4j that is using the driver in the background. But Neo4j migration directly uses the driver for this. Yeah, as everything Michael and me do, it's more pragmatic, and you cannot do maybe not so much as you could do with Liquid Graph, but it solves such problems, for example.
Yeah.
And coming back to the topic, what we have dropped is, for example, relationship entities. That was something that also confused the users a lot. Not the ones who are really, not everybody, of course, but we heard questions about that and thought about how might this concept be wrong. So when we speak about relationship entities, we have to mention that we have two types of entities in OGM, node entities and relationship entities. So one for the circles and one for the lights. And when I personally think about relationships and relationship with properties, so the need for the relationship entities was that you can not only attach properties to those nodes, like a user has a name and he has a pet called something, you can say the user owns as a relationship this pet, and then you could put in information like since, for example. Mm-hmm. So people wanted to access those relationships directly. In my head, a relationship is because of the schema-less thingy, it's a mapping table in the relational world. And I think when you're looking into your domain with this, with the domain view, you wouldn't ever access your mapping tables directly, but you would start at the entity that then has this what's it called? This one to something mapping annotation on it as a property or on a property. So this is something also be removed. So there's still the support for having relationships with properties in there, but they are just intermediate classes on your Java object graph, in your Java object graph to follow through. In the end, you point to another node, entity, or node, and then to persist this relationship.
Yeah.
There were users asking us, and because it's not in the nature of Neo4j, to just return relationships. You always have to return the start and the end of a relationship. And people were confused that OGM updates also those start and end nodes when you make changes to the relationship. But that's just out of it. Not, of course, we could just ignore the changes, but if the changes happened, we have to persist them, because otherwise we would run totally async from the database state.
Yeah.
And something like this. So this is something. Well, these both are the, I would say, the main topics we dropped intentionally.
Okay.
In there, but the rest of the migration should be easy is the wrong term. Of course not. I won't say if you have a full-fledged enterprise application that it's easy to do, but there are certain patterns you can follow. We started with a rough migration guide in our documentation. Will continue working also with other teams within Neo4j to provide migration material for the migration to SDN6, coming from OGM or from SDN OGM. And I think it's very, it should be helpful if there are any questions. I hope no user will just hold on and wait until more informations are there, but ask us. So I cannot post in the channel. So we have a community page, community.neo4j. Oh gosh. .com.
Community.neo4j.com.
Community.neo4j.com, yeah. And this should be the place to ask questions. Of course, we monitor also Stack Overflow and similar, but to get at least my attention, it is this community side first. So if I have time to answer questions, the first thing I go is the community page. Yeah, and if you experience any issues, we have for SDN6 now, we are still on the Jira of VMware part. Yeah. First ask questions and then create tickets.
Yeah.
We know it's a new world to work with. We know there will be bad feedback coming in, of course, but we think we took the right decision to make this.
Yeah. Well, it sounds like you had very good reasons, and I mean, as long as you still support at least most of the, or almost all of the important features, the migration shouldn't be too big of a deal. I mean, sure, it will be work. There will be issues with it, as with each and every migration. Every developer who has started migration knows that it never goes as smooth as you might think in the beginning, or as the market teams promise. But that's just how it is. And I mean, you said the latest version will be supported for at least 2 additional years, because the Neo4j Spring Data Neo4j OGM version. So there is some time to implement the migration. And
yes,
well,
and I think it's worth the effort.
Yeah.
To do this. So.
Okay, maybe we can take a look at the chat, and we had 2 Neo4j related questions there. But I'm not sure if the first one from Anshul is what the actual question there is. No SQL versus Neo4j. Well,
yeah.
Well, we talked in the beginning about when to use a graph database like Neo4j. And well, as with each and every data store, you need to pick a use case that actually fits you need to pick a data store that fits your use cases you need to implement. And for Neo4j, I would suggest that use cases where you work with highly connected data and where the relationship between the data is the important thing, right?
Yes, I would just say yes to this. It's what was in my head. So even if it's not a question, I think I love this three words: NoSQL versus Neo4j. It tells us that we are not NoSQL anymore, but we are the graph database space. Not only Neo4j, but there are other databases. I at least heard that there are other graph databases. But yes, I think the graph technology or graph database technology is so major that you can give it its own space and not put it just under the label yet another NoSQL database. And yeah, now I remember something I want to add. We speak now all the time about the Spring Data Neo4j and how to map objects. The good thing, if you do not want to map objects and you have so many data in there, we provide a lot of algorithms and similar to work with the data you have in your database. So what we are doing in Spring Data Neo4j is maybe it's even an atypical use case for a graph database. So we store data you put in and retrieve this data again. But the most common use cases for graph databases is to dump data there, make cool relationships, and then ask the database questions about the data you have in there. This can be achieved through our, for example, graph data science project. It's also, hopefully I'm not lying here, it's also free to use. Back then it was graph algorithms, where you have a full set of things you learned at university, for example, and you are happy to see this again, because you maybe have failed the course, and it brings back memories. But yeah, so you can really apply science to the data you have in there. Of course, it's not excluding relational databases with throwing algorithm it is, but I think it's a more typical use case for relational database to persist and retrieve data as it is, and not to try to get more information besides aggregations out of those data. But for example, you can have your own page rank running on your data. So similarity, neighbors, most influencing node, depends on your data and the questions you want to ask. But there's this library to have you covered.
Yeah. And I think I think I saw a presentation from Michael Hunger about the additional query capabilities and this science module and everything. It was really interesting. And if anyone is interested in that, I recommend taking a search on. It's probably on YouTube. I think I saw it
maybe
in person.
Search for APOC. So APOC, APOC, awesome procedures on Cypher. It has nothing to do that our query language is named Cypher and APOC, and we all love the metrics. So that would be copyrighted. So we cannot say this. That is related. But the APOC library is something in between. So between the heavy scientific-driven GDS library and the feature set Neo4j brings with it. So APOC is tool set to work with Neo4j. So APOC gives you iterative imports for CSV data. It gives you JSON imports for first of all the importing stuff. It gives you the ability to connect to your JDBC data source and import data. Yeah, but it's also, yeah, you have to look into it. It's a nice tool set.
Yeah. No, highly recommend taking a look at that when you are giving Neo4j a try.
Yeah.
Okay, and then Ashish asked, how about size of the storage? I've read that it consumes less in graph database compared to relational database. Can you tell us more about how data is stored in file system for Neo4j? Yeah.
So the question is not silly. I cannot answer it in full-fledged because I'm this high-level abstraction developer, but and not working in the kernel system. But basically, you could imagine for simple data that has not a prose as a string stored or similar, that we store this data like you would expect it as a graph, also in the file system. So a node, and now I make numbers up, is, for example, 8 kilobyte block that has at the end informations about the relationship it's pointing to, so memory addresses of the following up nodes. Of course, there are scenarios where this does not apply, but for just to get a picture in your head, this might be the best explanation. And it points to another node. And this node might have also relationship and point to another node. Of course, this relationship or memory addresses at the end are limited. So you cannot have an unbound number of relationships that then persisted in this 8 kilobyte block. But I hope you get the image right. So we have also a graph database more or less on your file system. But as it is with every database, give Neo4j enough memory and it will not access, well, hopefully it has not to access the file system so often and can work directly from memory.
Yeah.
But yeah, that's the only thing I can explain. Does it really have less storage needs than a relational database? So what is a relational database? Is a relational database in MySQL and Maria, a Postgres, or an Oracle? So maybe we have less storage needs than DB2. I don't know. But I think storage itself is nothing you would think about, or the storage price, when you run an enterprise application. It's nothing that we haven't seen, that people are storing billions of nodes and querying it. Of course, not everything at once, but yeah, selecting things out there. So it's, yeah, I can persist a small IMDb example and work with it, but there are also people persisting a bunch of data, really bunch of data, into Neo4j and then asking questions.
Yeah. Okay, maybe take a look at the,
As a disclaimer, just as a disclaimer, do not try to use an object star mapper against such data amounts. I think this also applies to Hibernate and similar, that I do the star in between and not only OGM. It will kill your machine.
Yeah, but if you fetch all the data from the database, then you hopefully have a lot of memory and enough time to wait until all of that is done. But that's always an issue.
or you're going reactive because we support this now. And then you have all your rules in there and filter rules and talk to the database. But I don't think that makes fun in the end.
Yeah. And I mean, even if you request the data in a reactive way, you still need to process it, right? So
yeah, you have to get it out of the system as fast
yeah,
as possible
exactly.
before you can process the next one.
Yeah, yeah. So yeah, using a reactive approach might give you a chance to actually process all the data that's stored in your database, but it will not be an easy job. And the question is, does that actually make any sense? But yeah, there will be some specific use cases for that for sure. Okay, then Skywatcher asked, what is the best way to speed up select when result set can contain 20,000 entities? And it's not query issue, it's really fast, but data transferring is too long. Well, that sounds like more of a JPA and Hibernate question. And well, my honest answer to that question would be try to not select 20,000 entities. I know that's not what you want to hear, Skywatcher. Well, if you select 20,000 entities, and that's totally independent of if you're using Hibernate and a relational database, or if you use Neo4j with its Spring Data module, then you have to send all the data over the network and process it in your Java application, which means map it to objects, and that always takes time. There's nothing you can do to prevent that. So if you say you really need to process these 20,000 entities, I would suggest to either split it up into multiple blocks, so use pagination to retrieve one block after the other. But if that's also not an option, then there's actually, well, then there's still one thing you can do, and that is add more hardware. But other than that, I mean, if you're selecting 20,000 entities, then you're transferring a huge amount of data over the network and then map that into Java object, and that just takes time. So first suggestion is refactor your use case so that you're not working with 20,000 entities. If that's not an option, split it up into multiple iterations. So work with smaller blocks. And if that also is not an option, move your application to the database or get a faster network or more memory. Option 3 is, of course, not really serious. You should opt for option 1 or 2. Refactor the whole thing or break it up into multiple blocks. Yeah. Okay, Garrett, do you have a way to work with this data efficiently in Neo4j? Any suggestions other than try a different approach?
Yes. So yeah, it's okay. This question now aligns with what I said before.
Yeah.
You shouldn't, of course, not do this within a mapper. But at least we are so lucky to have this in graph processing. But yeah, I would say you have to lower this to chunk it, as you did, and then make sense of it. I know that there are also Hibernate loves to cache, and there are several keywords you can fall into when not clearing your cache doing the processing.
Yeah, you could, with Hibernate, you
Yeah.
could do a flush and clear every few thousand entities that you process, but that would also require you to split the query up into multiple ones that fetch multiple batches. So what you could try there, and that would be basically option 2 that I mentioned earlier. You split the query up into one that uses pagination to fetch, let's say, blocks of 1,000 entities. And after each of these blocks, you would flush your entity manager and the persistence context it belongs to, which means replicate all pending changes to the database, and then clear it to remove all entities from the first level cache, which is also the persistence context. And that would remove the biggest issue with your cache. If you're also working with the second level cache, then we would need to look a little bit closer into that and the cache configuration for that specific use case. But still, you're putting a lot of effort into something that should probably just in general be done in a totally different way, because I don't think that even if you put a lot of effort into optimizing a use case that fetches 20,000 entities, you will actually get to the point where you have a good performance. It's just too much data that's processed in one request.
Yeah, all the question is related to your network, but
yeah,
because I've just read again, yeah, transferring. So what is transferring in this question? Yeah.
Okay, any other questions about Neo4j, Spring Data Neo4j, graph databases in general, and or other Java persistence related topics?
Yeah, and if you can come up with a question right now, but after this session you think, yeah, I have this question, just reach out to me. You see my Twitter handle there.
Yeah, that would have been my next question.
Oh, sorry.
Yeah. How can we get in touch with you if we have any further questions, or if well, if we have further questions we would like to discuss with you? And the second thing, where would we go if we give the new Neo4j module, Spring Data Neo4j module, a try and run into issues?
Yeah, so I think it's beneficial for all to ask those questions. For example, on the community page, you post the link. That's mainly because I think it's helpful for others to see those questions and the answers. Maybe somebody is not so encouraged to write this question down and has fear of asking the wrong question. I don't know. At least they can read it up later.
Yeah.
Yeah, and if you want to have more direct contact, it might be Twitter.
Yeah, that's a general recommendation.
Oh yeah, we have a Slack channel. Just give me a second. We have, of course, a user Slack channel. So, but there might be. Can I? Yeah. Just a second. So I just sent you the link. So we have this user Slack. Still need to figure out how you get into this because Slack is this invite thing. There.
Okay, here it is.
Hopefully this is not a scam page. This is your access to the. Yes.
Okay.
And then you can also drop a direct message to me.
Yeah.
Ooh.
Okay. Then, Garrett, thank you a lot for joining us today and for giving us a few more information about Spring Data Neo4j and changes that are coming up.
Thanks for having me. Thanks for the invite. It was fun.
When will the release be available? You are part of the official Spring release, right?
Of the what?
Of the official Spring release. So you're not releasing it independently. It will be part of the.
No. Latest I've checked is end of October.
Yeah.
Just let me type directly in front of the microphone.
Okay, so most likely at the end of this month, October
Yeah.
2020. If you're watching this stream later, stays up as a recording on the channel, then you might already be able to use the official release. Right now, there's a release candidate available. You can give it a try, play around with it.
You can, yeah, if you opt in for the latest Spring Boot milestone release or snapshot for the 2.4 version, you will get with the Spring Data Neo4j Spring Boot starter, or how the order is, the latest RC also.
Okay.
So it's easy to get a version running within a Spring Boot application directly from the start of Spring.io page.
Awesome. Okay, yeah, then let's wrap up this stream again. Thanks, Garrett. And I hope you will join us again in the near future. Maybe after the official Neo4j, the official Spring release is available, and you're working on the next milestone and interesting changes that will probably come up with the next version of the Spring Data integration. And well, here on this channel, we will have another video tomorrow about Hibernate. The live stream Coffee with Thorben will probably take a pause for 2 weeks. We have school vacations coming up here, and I will probably be busy on Wednesday afternoon with other things than working and doing live streams. But in 3 weeks, which is the 28th of October, I will definitely be back. So take a look at the channel announcements and subscribe to it. Then you will definitely learn if there will be a spontaneous stream next week or the week after. Otherwise, we see each other again in 3 weeks. Have a great rest of your week. Again, Garrett, thanks.
Bye.
And see everyone later. Bye.